Now let's look at how we can predict the products of addition reactions. To start off with, we need to remember that the reactants will be alkenes or alkynes, and that they will give us different products. When we do an addition reaction, we know that whatever we're adding is going to add across the double bond. That means that we will be removing the multiple bonds, the double bond or the triple bond, and we'll be replacing it with a bond to either hydrogen or halogen or possibly water. We're going to break the thing that is being added into two parts and add 1/2 to one side of the double bond, 1/2 to the other, at the same time removing that double bond. The groups that are added are hydrogen, a halogen represented as X2, or water. Let's look at each of these individually. Let's start with the addition of hydrogen to an alkene and an alkyne. When hydrogen is added, we're going to take the two H's and separate them so that we can see them on each side of the double bond. First, we're going to add a hydrogen to one side. We're going to break the double bond, make a bond to the other hydrogen, and break the bond between the two hydrogens, so that we are making a bond, breaking a bond, making a bond, breaking a bond, so that the total number of bonds is the same, it's just bonded differently. As we do this, we go from an unsaturated alkene to a saturated alkane. This reaction is called hydrogenation. When this reaction occurs on an alkyne, the hydrogen is added twice. So we make a bond, break a bond, make a bond, break a bond, and then we do it again. Make a bond, break a bond, make a bond, break a bond, so that when we're done, we have an alkane with two hydrogen groups added on instead of just one. Now let's look at the addition reaction of halogens to alkenes and alkynes. This reaction is very similar to that of hydrogenation of alkenes and alkynes. In this case, we'll be using X to model the halogens. The halogens can be fluorine, chlorine, bromine, or iodine, and we'll be adding them across the double bond, similar to the way that we did with hydrogen. As we did with the hydrogen, we're going to spread those two X's above the double bond, and then we're going to model this by making a bond, breaking a bond, making a bond, and breaking a bond, so that we end up with a type of alkane. But in this case, it's called a halogenated alkane. We have again gone from an unsaturated compound to a saturated compound, and this process is called halogenation. This reaction is often used to identify how many multiple bonds are in a compound. When we've used this reaction with bromine, we call this the test for unsaturation. When we do this reaction with alkynes, we see that this reaction just happens twice. So we'll need two of the X2. One set will be above the triple bond, one will be below the bond, and we make a bond, break a bond, make a bond, break a bond. And then we repeat that by making a bond, breaking a bond, making a bond, and breaking a bond. And that is the overall reaction. It does give us an alkane, but it is a halogenated alkane. But in this case, we have 4 halogen atoms added across the triple bond. We'll look at the addition of water to an alkene. It will react with alkynes, but it does a rearrangement, so we don't talk about that in this class. In this case, as we look at water, we're going to split it into 2 parts, but they aren't equal parts. One side will be the hydrogen alone, and the other half will be an OH, so that when we add them across the double bond, we'll be adding H and OH rather than just water. So let's write that above the double bond, and then we're going to make a bond, break a bond, make a bond, break a bond. And in this case, we end up with a compound known as an alcohol. You will not be expected to know which alcohol you get, but you will be expected to know that an alcohol is formed. And that is the last of the addition reactions.